Hi guys, welcome to my YouTube channel. So yeah, we have now created a couple of walkers which are, well, you can't exactly call them walkers. They are more like crawling still from endpoint to endpoint. They're like toddlers at this point in time, and they just know how to, say hi to an API, and that is it basically, right? So what are we exactly missing? Well, we are missing the AI side of things, right? So in our last video, we created a few AI utility functions which really add a spice into our system and make this more of a smart expense tracker. And today, we will be implementing a couple of AI integrated workers. So stay tuned for that. So I thought of, before we go ahead and add a few AI workers, we kind of just make sure that, our code is healthy. There are no errors, no redundant code and whatnot, right? So I wanted to start off with this. So you can see there are a few utility functions here we've defined in our main.jack file. And also we have defined the same functions in our utils file, right? So let's get rid of these functions since we don't need them in our main implementation. And also in this utils file, we don't need to, keep on importing the same library repeatedly. So this is redundant, right? So let's get rid of all of these codes. Um, that, and let's place it on the top of our script. Oh, actually, it's already defined on the top. So yeah, that's good. Okay, my bad. Right. So, yes, let me just save these two files. And another great way of actually, seeing whether our code has any syntax errors or not, whether it's actually, uh, standard. We can run this line in the terminal. So it's called jack run. And then you type the file name. So let's check the main.jack file first. It'll be doing the runs sequentially, line to line. And if there are no errors, there will be no problem at all here, right? So it looks like the main.jack file does not have any syntax errors. Let's do the same for the other files as well. utils.jack. Okay, so there is an error here, and it says that can only concatenate string. Okay, this is regarding our currency API implementation, the calling there. So the issue is this: it's saying that it can only concatenate a string, not non-type to string. All right. What can we do here? Okay, I think there's another issue with our imports. I think first of all we need to import our load.env. Then yes, glob env loaded. Yeah. Right. Just add a comment here, load. Right. So now this will be recognized as a string. Let's see. I'll save this and let me just run that again. Yeah, okay, that is fixed it, right? So the issue was that this was not recognized as a string object, since we are, even though we are calling it, we are not calling the env properly. So now it has got recognized that it's a string, and now it's good to go. And we have one more file we need to double check. That is our AI utils file. Let's see. All right, yeah, that is also all right. Cool. So let me just close this. And now we can start building from where we left off. Also, actually, one more thing. So I went through the latest documentation of Jack, and there are a few issues we need to look over. First thing was import from byLLM is actually was kind of deprecated a couple of versions ago. So the latest one is actually byLLM.lib or lib, right? That is the correct library we need to import these packages from. And also, another issue I noticed was this empty image. It should actually just be image. That would make more sense, since we are importing image here. It's an image type object. So that's clear. All right. So next is um, there's one more thing actually we need to add here, right? So we are extracting this expense from an image object, and basically what that does is, yes, we have implemented the functionality in terms of actually extracting the expense detail from an image, but from an image object. But in addition to that, we also need to create a function that could take an image file path and pass that as an image object, right? So we need to first define that as well in this AI utils.js file, and then we can go ahead and implement the couple of walkers we wanted to. So this one you don't need a separate semantic object. So we are just dealing with a file path. So let me add that extract expense from image. Just say file. Yeah, this should change. Dict, right? This looks okay, I believe. So image is what's passed here. So yeah, we're getting from a file here, but so the issue is this. What we will be doing is we need to define the path here as image path, correct? And we are returning a dictionary with the amount, currency, date, category, merchant, and confidence. Um, we take an expense, I guess what we need is there. Get the merchant and amount, yes. So I think this is okay. This is fine. So let me just save this. And once more, let us have a check run this file. So let's see what happens. Okay. All right. So there's no module name byLLM.lib. Okay, so let's see what's going on there. Let me just check our requirements. All right, let's just install byLLM here. Control S. Let me create a new terminal. Right, cd backend, then pip install. Okay, so we install byLLM, and let's create a new terminal. And let's go to the backend. Backend check run ALTs. So let's see if it has got resolved. No. Okay. So I mean, Jack is a relatively new language. Let's see. This should be a major issue. So we didn't face this issue before when we just used input from byLLM. The latest version requires this .lib suffix at the end. But it's not a big deal. We can fix that later on. Now comes the exciting stuff, right? So here's our main Jack file, and we have about 257 lines of code. And now we are going to further extend this by implementing a couple of walkers, more AI, actual artificial intelligence integrated walkers, right? So let's go ahead and start defining. So one is we are going to create a walker that by just uploading an image, we are going to be able to extract the details of that expense, right? So that sounds really, really cool. So how can we do that? Let's see. So walker, let's say add expense, yeah, add expense from image. All right. So it has done a lot of auto completion for us. Let's see. All right. So add a new expense by extracting details from a receipt. Image has an image path, and okay, with the root entry, we are visiting the user node, and then we can create an expense with user entry, expense data, and then we are calling this function from the image file. So here itself, we are getting the image path here, right? And we define a function to which already calls this method, extract expense from image, which actually takes that image object, that byLLM object, and does the it has the schema, right? And it does the actually it's this is the schema, and we have a semantic object here, right, which basically does the expense extraction for us using semantic understanding. So okay, so we're getting the expense data here, and then we are going to find the matching category node. Makes sense? Yes. So from each category, we are going to kind of see whether it's there. And okay, what's going on here, right? If cat.category type equals expense category.other. This seems a bit off. Okay. So if the expense, yeah, so we have the category inside this object, the expense data, right? I think we've defined it. Yeah, it has category. Um, yep. So dot upper is equal to cat dot name dot upper. We don't even need to put dot upper here again. Fact. It's already in uppercase. Target category will be equal to cat rig. Yeah. Yeah, that looks okay. And in the case that's not there, yes. All right. So once we've identified the category node, we will add our new expense node to that the corresponding target category node, right? So we are having the amount, currency, amount in USD. Let's just remove that one. We don't need that. Oh wait, let me just see. Let's see. How have we defined our expense node? So we have defined our expense node. Okay, we have an amount in USD field as well, so we have to define it there. Okay, and then once we have created that, once we have entered it to our target category, we get the report from the worker as usual, and that should be fine, right? So very, very easy, right? When we are coding with Jack, as you can see, we are not coding lines, we are not putting any prompts or anything as such. It's very, very just using semantic understanding, structured logic, schemas, methods that it can use, and we get a simple add expense from image, right? Next, let's add a worker that can also, basically extract data from text, right? So add expense from that came a bit expense from text, yeah. So let's see how the implementation here has happened, right? So add a new expense by extracting details from a text description. So yes, that's what we want. It has a description, we can process text with the root entry, okay, then we visit the user. And again, here we're extracting the expense from the text, that's description, okay, cool. So target category, again, we're trying to match the category node. And if it is not there, we get the expense category other, and then we do the creation, right? It's very, very basic from there on. It's the same thing as how we are extracting details with an image afterwards. So, okay, there's a small problem here. You see this expense ID, that was an issue back then as well, right? So there's no expense ID per se. Instead, we can have, maybe we can have the merchant. Yeah, merchant, that's enough. And I think the previous one, yeah, here also the same error. That's it, autocomplete. And right, okay, cool. So we've added 2 new walkers. Let's add maybe one more. What more can we do? So we have now AI utils file, we have extract expense from text, extract expense from image. We use those two. What about passing the natural language query? So when we ask a question, a simple question, our walker is able to traverse the graph and retrieve the details we are hoping to find, like what we are looking for. Cool. So let's add that as well. So let's say walker to query expenses. Okay, I'm just waiting for it to autocomplete as usual. Okay, here we go. So query expenses based on natural language input. Correct. All right, let's see how it has come. So we have a query which is a string. So okay, let's see. So what is our function? We have a string here. Okay, we have a string and then we query the parameters by LLM using this. So yeah. So we can call this function if we have this as an input. Let's see. Okay. So we see the user node can fetch expenses with user entry params equals to parse natural language query self.query, and we are met with this schema, right? Yeah. Okay. Filtered expenses. So filter expenses based on the parse parameters for cat in the categories if it's not equal to this. Okay, so we are first of all trying to find what category it belongs to, and then date range filtering, among comparison filtering. Okay. So what we're doing here is we are extracting a date range, we're extracting a category, an operation like find, show, maybe the sum of the amount you spent on transport last month or the last week, and what. And then we have comparisons, we have merchant, right? So so this looks it's not comprehensive, but it looks like it's something we can work with. And I don't want to go too deep into this particular worker. What we want is, so we have a worker that can query expenses, and I think we can fine tune this further based on trial and error, right? So it looks like we have comparison filtering as well. So we have greater than, less than, if it's equal. Then we have merchant filtering if you want to know how much you spent at a particular store, particular merchant or whatever, you can use this. And then we are getting the expenses filtered into what we exactly want, and then we are reporting what the query was and also the result and whatnot. So filtered expenses is this, right? So we are storing this also in like kind of an object, a dictionary to show, okay, this is the amount, this is the merchant if there is a merchant, and so on. Right, so I think we have put in the 3 AI walkers based on the semantic objects we defined last week. So yeah, that is it for the coding side of things today. So yes, that brings us to an end on this video, and I explained how we can get AI walkers using our AI utility functions we defined last week. We defined some walk endpoints where we can extract expenses from images, from text, and we also looked a little into the query expense walker. So that was implemented on a very basic level. Next week we will maybe add more functionality. I will come up with a plan on how we can query expenses in a robust manner, and we'll also run a few tests like we did a couple of weeks ago to see how our endpoints are working, whether the system is working as we expect. And yeah, so let's lots to look forward to. And once we are done with testing, we will go ahead and start working on our front end to create a user-friendly experience in terms of our smart expense tracker. Right, so yeah, if you really enjoyed this video, please leave a like, subscribe to my channel, drop a comment, let me know what you enjoyed in this video. If you have any constructive feedback, please let me know, and I'll see you again next week with a brand new video. Ta-da!